Hi everyone, welcome to Mash Math. Today we are going to study from class 10, chapter 3, pair of linear equations in two variables. In this video, we are going to study the introduction for exercise 3.2. Before coming to this introduction part, let's go back to exercise 3.1 that we have studied. Exercise 3.1, I am just taking the last question. So in this question, you saw that the situation is given to us and we have to represent the situation algebraically and geometrically. So what we did, we represented this situation first algebraically. So we found these two equations. Out of this situation, we have written these two equations. This is algebraic expression. And after that, these algebraic expressions, we have expressed it geometrical presentation, or we can say graphical presentation. So what we did, these two equations we have written down separately, and then we found out the x values and y values. In another word, we found the solutions. Okay, so when we got the solutions, what we did, we plot the graph. So here we had plot the graph and we got the graph like this. See both the equations. This first line is of this equation, another line we got of this equation. So we got the graph parallel lines. Now what we are going to do here is, without doing all this procedure and without plotting this graph, just only looking at this equation, can we come to know that what type of graph we are going to get? So that's what we are going to see. You have the method here, method to solve pair of linear equations in two variables. We are going to see in detail the graphical method. So without plotting the graph, we will come to know what type of graph we are going to get just by looking at this equation. So here I have taken some examples. Two equations are here, and let us solve these equations. We know these are coefficients. This is coefficient, right? 2 is a coefficient. This is coefficient. This is A1, this is A2, and this is B1, and this is B2, and this is C1, and this is C2. So that we have studied already in the introduction part. Okay, so what we will do, we will compare this A1 upon A2, B1 upon B2. This we will compare and see whether they are equal or not. Okay, so this is A1 is 2 upon A2 is 3, and we are going to compare. So we'll put the equation sign, and then 3 upon 4. So this is B1 and this is B2. First we'll compare both. So when we compare both, we can see here this is 2 upon 3 and this 3 upon 4. So this cannot be equal. So that means this is not equal. So you see, whenever equation is given to you, you find that A1 upon A2 is not equal to B1 upon B2, then we will get the graph, sure to get the graph intersecting lines. So our graph will be like this. When we plot if this equation, if you find the solution and then you plot the graph, then surely you will get a graph that is intersecting. So here we don't need to do the graph, but I'm just explaining you. So this type of, when you get the equation and when you solve and see like this, and if you find this condition where A1 upon A2 is not equal to B1 upon B2, then our graph will be intersecting. And when it intersects, there is at one point where both the lines they meet. So when you get intersecting lines, we say that we get one solution from these equations. These equations will give us one solution, or there is only unique solution. Intersecting lines will have a unique solution or one solution, meaning both the line will touch at one place. And this type of equations we call consistent. So this equation is consistent. When we say consistent, when we get the solution. So in this graph we are getting one solution, at least one solution we are getting. So this equation is consistent. Okay. So same way, you see now another condition. If you get the equations and then you compare and see. First both you compare and see. This is a1 upon a2, right? So 2 upon 4 equal, this is 3 upon 6 equal sign you have to put because we are comparing. This is 4 upon 8. This is 4 upon 8. So let us compare and see. So if you are dividing this with table 2, this will be 1 time and this is 2 times. So we get 1 upon 2. Here if table 3 you divide, this is 1 time, this you will get 2 times 6. This also 1 upon 2. Now here table 4, 1 time and 2 times will get us 8. So now you see this is 1 upon 2, this is also 1 upon 2, this is also 1 upon 2. That means all three are equal. So when you get like this condition, so when you have an equation, you see like this. So if your condition is where a1 upon a2 is equal to b1 upon b2, which is equal to c1 upon c2. So if you first you see both, if both are equal, then you compare with the third one. So then that also is equal, then all three are equal, then you will get a graph that is coincident line. So the graph will be coincident. So first line means for first equation when you prepare, you will get one line. Okay. Then second equation, for second equation if you are finding the graph, you are plotting, then that line also will come on the top of this line only. This top of this line only, that also will come. That means both the lines will be coinciding. If both the lines are coinciding, how many points, how many solutions we have? Plenty of solutions. All the points they are touching. That means infinite number of solutions we will have. This type of graph we will get where we will have infinite number of solutions. And since we have the solutions here, we call these equations are consistent. I already told you that when we get the solution, then that equation we say consistent. Here also we get infinite number of solution. So this equation also is consistent. So now let's see the third condition. So here another example I have taken. So let's see here. This is 3 upon 6 equal, this is 2 upon 4 equal, this is 4 upon 9. Now let us simplify and see. With table 3, this is 1, this is 2 times 6. This table 2, 1 time, here will come 2 times. So both are equal. Let's check this one now. Now this is 4 and this is 9. Can we divide this? No, because this is even, it is odd number. So you cannot simplify this with a common table. We cannot simplify. That means this is not equal. Okay. So this type of condition when you get where a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, then our graph we will get parallel lines. So first equation will give us one line and then second equation will give another line. They will not touch anywhere. So we get parallel lines. So when we have parallel lines, then we don't have any solution because nowhere it is touching any common point. It is not touching and therefore this will have a no solution, and this type of equations is called inconsistent. This is inconsistent. Now let us check the third one. So I already told you this third, when we saw these are the two equations, and when we plotted the graph, we found out the solution and we plotted the graph, we got the parallel lines. We got the parallel lines. Now without plotting the graph, what type of graph we are going to get just looking at this equation? So let us see this. This is 2x. This is 2x plus y equal to 160 and this is 4x plus 2y equal to 300. So let us compare and see. This is 2 upon 4 equal to, this is 1 upon 2 equal to, this is 160 upon 300. So let us compare and see. Table 2 it will come once and it will come twice. Now already this is equal. This both, this is 1 upon 2, this is also 1 upon 2. These are equal. So now this is 0, 0 gets cancelled. And then let us divide this with table 2. Let us cancel 8 times 16. Then with table 2 if you cancel 15 times you will get. 15 times 2, 30 we will get. Now this is 8 and this is 15. Can we further simplify? No. So that means this is A1 and A2. So A1 upon A2 is equal to B1 upon B2. But not equal to, this is C1 upon C2. You saw this condition? Here both are equal, but the third one is not equal. So you see the condition? When C1 upon C2 is not equal, our graph will be parallel. So you have seen that for this question we had solved the graph and we got our graph parallel. So I hope now it is clear to you. So without plotting the graph, just looking at the equation, when we do this comparison and we find out, so we will come to know what type of graph we will get and when we can get the solution also. So if first condition is there, so in this condition we get the intersecting lines where we have only one solution or a unique solution and it is consistent. And in this condition where all are equal, we'll get the coincident line where we'll have an infinite number of solution and it will be consistent. And if we have C1, C2 is not equal to the other, then we get parallel lines where we have no solution and the equation is inconsistent. I hope it is clear to you. Thank you. God bless you.